Hello, live math class. Tonight we're continuing our look at area of the triangle, but this time we're not just finding the area of the triangle. We want to make the same comparison that we did when we found the area of the square and the rectangle, and we looked at how scale factor affects area. So if you missed that class, you can check that out on the channel. We did two videos. The first, we looked at area of the square, area of the rectangle. And then the second video, we looked at how changing the length of the square or the length of the rectangle by a scale factor, how that affects the area of the bigger or smaller shape. So we're going to try the same thing with the triangle. Last week in this class, in the formula class, we looked at the three ways of finding the area of the triangle. Half base times height, or half AB sine C, or Heron's formula, depending on what information you're given. So we're going to look at different triangles, find the area, and then we're going to extend the lengths by a certain scale factor, and we're going to see if the same thing applies. If expanding the length affects the area by how much. And we're going to remind ourselves what we discovered for the square. So let me first invite my in-studio scholars. Welcome Asar, welcome Imani.
Good night, Miss. John will be here soon.
Okay, so John is not here with us. Hi Asar. All right. So I'm sharing my screen. So it's that one. Okay. All right. So earlier today, when we're doing other classes today, students were saying that at certain points the screen was black. I'm just doing a test. Are you seeing the screen now with the two white rectangles?
Yes, Miss.
Or you just see that? Okay. All right. So I wanted to know if when I switch back to studio, if you're not seeing the screen properly. All right. So let's go. Imani, do you remember what we discovered? The relationship between, or Asar? I think was it Asar here or Dreshan? When we're looking at how it was Dreshan. Okay. How scale factor affects the area. Do you remember what we discovered, Imani, for the
Miss.
square and the rectangle?
Oh, Miss, that's the. Okay. Miss, that the when we have a certain square factor, Miss, it changes the area by a certain amount. So, if the scale factor. So if it has a scale factor of 2, the area would be 4 times the what it was.
So what do we do to the scale factor? How you got that for?
Miss.
And suppose the scale factor was 3 or 5.
Oh, okay, Miss. I have it here now.
Mm-hmm.
Miss, it would be squared, Miss. You'd square it.
Okay, so you would square the scale factor. So in other words, if the length of the original square was 2, and then we increase the length to 4, or let me not use 4. if we increase the length to 5, so that would be what, 2.5?
Mrs. said two half of five.
Or let's say it was 2, we increase it to 6, right?
Yes, miss.
So the scale factor is 3.
So miss,
The bigger one is 3 times the length of the smaller one. The area of the bigger one would be, you'd have to square the scale factor. So 3 squared would be 9. So it would be 9 times the area of the smaller one. That's what we found, right? What we did several experiments with the square and the rectangle. So we're going to see if the same thing applies to the area of the triangle. So let's start with the regular right angle triangle. All right, so John, you do this one for me. So let's say that's 6 meters. That's 8 meters. And that's 10 meters.
okay, miss. So miss this. Okay, miss. So miss, the scale factor is 10, miss. So miss, with square
No,
tail
no,
of
no. Hold on. I don't tell you.
Let's go.
I have to tell you the scale factor. So let's say the scale factor is 2, right?
is 2.
So we're multiplying each length by 2. So the bigger triangle then would be,
Miss, miss.
it would be what? So this length would be 6 times 2, right?
Yes, miss. Oh, wait, miss.
12.
6 times 2.
Because the
Miss,
scale factor is 2, okay?
yes, miss.
And
But
this
wait,
length would be what?
I'm confused. Miss, that would be 20, miss. 20 meters.
All right. And the other one would be what?
Miss, the other one would be 16 meters.
All right.
Oh, miss.
So let's find the area of each of them and compare, right?
Yes,
All right. So what would be the area of the small one?
miss, the 12, miss, the area of, miss, the area. So miss, would multiply it by itself, right, miss? 'Cause
Hmm?
miss would be multiplied by itself.
Multiply what by itself?
Miss 12, miss, since it's smaller one.
No, man. The smaller triangle.
Oh, miss,
What's the
okay.
area of this small triangle?
Okay, miss. The area. Miss, how do you find the area for a triangle?
John, weren't you at the
Oh,
class last week when we
yes,
were finding area all over the
yes, miss,
place?
miss, I was at the class.
Yes. So, or you forget.
The-
Half base times.
miss,
So
miss,
it's
the
half
half.
base times height, right? Half of the base times the height. Okay.
So, so miss, so miss, the base is 8, miss, and half of 8, miss, is 4. So miss it
So
before.
half of 8, and the height is what?
Miss, the height is 6.
Half of 8 times 6. How much is that?
So miss, it would be uh, miss 10.
10, John?
Okay. So miss, I would find half of 8 and 6, miss.
No, one of them, just one of
Okay.
them.
So miss, I'd find half of the base, miss, is 4. So miss, before times 6, which is 24 meters square.
Okay, so the area of the first one, 24 meters squared. Okay.
Okay, miss.
All right.
And next one is half base, which is 6. So miss, half of 16 times 12, which is
So half 16 times 12, and that's how much?
okay, miss. Miss, that would be that would be 96
96.
meters squared.
All right. So what we found with the square and the rectangle is that the area of the bigger one, we square the scale factor to see how much bigger the area is. So here the scale factor is 2. 2 squared would be 4. Is this triangle, is the area 4 times that one?
Yes,
If
Miss,
we
it is.
divide, so 96 divided by 24, is that 4?
Yes, Miss, it is.
Okay.
Miss, it's
So,
24.
so far, so good, right? It
Yes.
seems like the same rule applies. All right, but we need to do more experiments. So, Asar, here's your triangle. The small one is our regular, everybody knows this triangle, the famous triangle. All right, so the scale factor is 4. So what will be the new measurements for the big triangle if the scale factor is 4?
The first measurement would be 3 times 4, so you get 12.
Okay, so 12. Mm-hmm.
The second measurement is 4 times 4, so you get 16
Mm-hmm.
centimeters.
Mm-hmm.
And 4 times 5, so you get 20.
All right, 20. All
And
right, so what will be the area of the small one?
half times 4 times 3,
So half 4 times 3, and that gives what?
2 times 3 gives 6.
So that's
The
equal to
area is 6 centimeters squared.
6 centimeters square. All right, and the area of the big triangle?
Half 12, half 16 times 12.
Mm-hmm.
So that would be 8 times 12, which is 96
All
centimeters
right.
squared.
All right. So how are we gonna test now? The scale
We're gonna,
factor is 4.
we're gonna square the 4,
All right. So 4 squared is,
16.
so we need to see if 96 is 16 times 6. Is that the case? 96 divided by 6.
Yes, miss.
All right. So this second experiment proved the same thing. The big triangle is 16 times the area of the small triangle, the scale factor being 4. So if we square the scale factor, it tells us how many times bigger the area now, all of the space taken up. All right, so far so good. So let's do another one. Madam Imani, this one is yours. So
Oh,
another,
yes, miss. I thought the mic was on.
oh, I thought you were sleeping. Why my triangle want to look like that? That's no way for a triangle to look. Okay. All right. All right. So we have 12 meters. Um, Not drawn to scale, right? 5 meters, 13 meters. And let's say the scale factor is 10, right? Let's use a big number because maybe it just work for the little numbers. Let's use a bigger number. So what would be the new measurements now?
Okay, miss. So the new measurements would be so for
Hmm? I think your mic tripped out.
oh,
Go
miss, can you hear
again.
me now?
Yeah, I can hear you.
Okay, miss. 120 meters is for the height,
Okay, so 120 meters.
and
Hmm?
then for the hypotenuse is 130 meters,
Hmm.
and for the base it's 5 meters, 50 meters. Sorry, 50.
50 meters. Okay. All right. So what's the area of the little one?
Okay, miss. So the area of this one would be half base times height. So
So half,
5 times 12, miss, and 5 times 12
which is
is 60, and half of 60 is 30. So 30 meters squared. Ah,
mhm.
Can you get them again?
All right. And the area of the big triangle.
okay, miss. The area of the big triangle is also half base times height. So half of 120 times 50, or 50 times 120.
And that gives what?
Miss, 50 times 120 is 6,000, and half of 6,000 is 3,000.
All right. So the scale factor is 10. So what's 10 squared?
Miss, 10 squared is 100.
So is the big one 100 times the little one?
Yes, miss.
So if we divide 3,000 by 30, we get 3 into 300 goes 100. So can we safely say the rule applies for triangles as well?
Yes, miss.
Yeah. So just find out what the scale factor is. By how much is the length of the bigger one greater than the smaller one? And once it's area we're dealing with, that's a different thing for volume, right? When we get to volume, we're going to see what happens
It's just
when we
next
get
week.
to volume. No, we're not finished with area yet. Next week, remember we have several different shapes to find the area of. We have so far for area, we have just done square, rectangle, which is basically square is a rectangle, and triangle. So we need to find the area of the trapezium, parallelogram and rhombus, irregular shapes, circle. We need to do all the areas first. And then we're going to go to volume. All right. So we can safely say then, if you know the area of the small object and you know the scale factor by which the length is multiplied to give the bigger object, to find out how many times bigger the area is, you square the scale factor. And remember, when we're doing the square and rectangle, we did some juggling. I gave you the area and then I wanted the scale factor. Remember that kind of stuff?
No, miss.
So I guess you don't remember, oh, John
Yes.
wasn't there.
No, John wasn't there.
Right. It was Imani and Drayshawn, right?
Yes,
So we
miss.
did some juggling with those. So the same kind of jugglings would happen again. If you know the area of the big one now, and you know the scale factor, so you would square the scale factor and divide it into the bigger area to get the smaller area, that kind of stuff, right?
Yes, miss.
All right, so we have proven that And what I want to do now is I want us to revise what we did last week for area of the triangle. So each person, the three ways that we use to find area of the triangle, I'm going to give you some quick ones. Each person gets one, and then we wrap it up. Okay, so do you remember those formula?
No,
Miss
miss.
this
I want
the semi perimeter and
So
the
this
half.
one that we just did, the half base times height.
oh that one. Yes.
And then we had what? Half AB sine C.
Yes, miss.
And
Yes.
then we had Heron's formula, remember?
Yes, miss. The semi perimeter
All right.
formula.
So we're going to start with the easiest one. So just do them quickly. So we're pretending this is a right angle triangle. So
You were here when you were doing this.
I forgot some of it.
You never wrote
Each
it
one of
down?
these I remember and the half it time. I don't remember
There's
the
half
next one.
A, B, sine, C.
Is it
all
that
right.
one the third?
Come, John, is your turn. Find the area of that triangle.
Okay, miss. So miss, I'm gonna use half bit. Oh. Okay. Mhm. Okay, so miss, I'll first have to find. Miss, I'll first have to find the the other miss the angle miss the
The
missing angle.
angle.
Miss the missing
You can tell me why John finding angle right now.
miss miss the missing number miss the missing number.
The length, the
Yes,
missing length,
miss.
right? Okay.
Okay, miss. So miss it be. So miss it be a squared plus c squared is equal to b squared.
A squared plus C squared equal B squared. I'm not
Yes,
sure about that. No,
No,
sir. No, I'm not agree with that one then. A squared plus C squared equal B squared. You sure, John?
miss is normally a squared plus b squared is equal to c squared.
So if you know C and B, how you find A then?
Oh, miss, you'd find the square miss and subtract them miss, and then you find the square root.
Okay, so do that then and tell me the length of the other one.
Okay, miss. Yeah, 10 squared is 100 miss, and 6 squared is 36. So miss, 100 from 36 would give you 60, 64 miss.
So you're saying the missing length is 64?
Oh, miss, and then I would have to find the square root of 64, which would be 8. Miss, 8.
Okay. All right. So you're saying to find this side here, and why we need to find that side?
Miss, because miss, if we want to find the area, miss would have to need, miss would need all the angles. I miss, sorry, I miss all the length, miss all the length, miss all the lengths.
If you want to find the area, you need all the lengths.
Yes, miss. Well, miss, the base, miss the base and the half, miss. And if you're going to use the one where you have the semi perimeter, you would need
Mm-hmm.
you would need all of the angles. Length.
All right.
What does it
All
contain
right.
angles?
Okay, I get what you're saying. All right. So you're saying, so we had 10 squared minus 6 squared would give x. And we need x because x is the height or the base, whichever you want. So 100 minus 36 would give x squared, and that was what, 64?
Yes, miss.
And so x is the square root of 64, which is 8.
Yes.
Oh my lord. So now that we know x is 8, what we plan to do now?
Once we plan to put it, as we plan to put it at the at the base, miss, at the base of the triangle.
So 8 is here.
Yes.
All right.
And miss, after that, miss, miss, am I supposed to use all three of them in one?
All three of what?
Miss, all three of formulas.
No, no. We're doing half base times height right now.
Okay, miss. So miss will do half base times the height, miss, and the base is 8, miss, and the height is 6.
So half 8 times 6.
Okay. So miss will
And that gives what?
okay. So miss that gives 24 meters squared.
24 meters squared. All right. Okay, Asara, you're up. Find the area
Okay.
of this right angle triangle. All right, so we have
That's it.
yeah, go ahead.
So to find the missing side, we have to say 26 squared minus 10 squared is equal to b squared.
Okay, so we're calling this B.
Yeah.
So 26 squared minus 10 squared is equal to B squared. All right.
No, 26 times 26. If you could write that out.
What's 26 times 26? You want to work it here? So
Sure.
26, 26. All right,
Well,
so
6
6,
times
6,
6 is 36.
and 6 twos.
12 plus 3 is 15.
Mm-hmm.
And then 2 times 6 is 12.
Mm-hmm.
And 2 times 2 is 4 plus 1 is 5.
Okay.
And when you add it, you get 6, 7, and 6
All right, so 676 minus
minus 100 is equal to b squared. And then 576 is equal to b squared. Square root of 576 equal b. And then 24 is equal b.
okay, so B is 24. Okay. Units.
Meters.
All right, 24 meters.
So we can plug that in to the triangle.
All right, so the area would be
Half of 10 times b, which is 24. And half of 10 is 5. And 5 times 24 is 120.
all right, so the area is 120
20 meters squared.
meters square. All right. So now we're going to use the Heron's formula. Heron's formula. What does Heron's formula state? Do you remember?
The area is equal to the square root of the semi-perimeter times the
So
semi-perimeter.
first, so the semi-perimeter, how we find that first?
That's half of the perimeter of the triangle.
Okay, so we know the perimeter is the distance around it, the triangle, or the length of all three sides. So the semi-perimeter would be side A plus side B plus side C over 2, right? Semi, half. All right, so Heron's formula says what? The square root of
The semi-perimeter
mm-hmm,
times the semi-perimeter minus a
mm-hmm.
bracket semi-perimeter minus b bracket semi-perimeter minus c.
Okay, all right. Okay, so first we need to find the semi-perimeter. Add the three sides, divide by 2, and then plug in that answer here, 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 and subtract each side from it. All right, Asar, so let's work one.
Okay, miss.
Using those same, we're going to use the same triangles that we did first, right? So we have 26, we had what, 24, and we had 10. So we know we can use half base times height, but we just want to practice using the Heron's formula. All right, so what would I do?
First, you'd find the perimeter.
So the
So
perimeter would be
that would be 10 plus 26
10
plus
plus
24.
26. And that gives what?
That gives 60.
So 60 meters. Okay, so the semi-perimeter would be
60 divided by 2.
60 meters divided by 2, which is
30 meters.
30 meters. All right, so now we're going to plug this into the formula, right? So the area would be the square root of, tell me now,
The square root of the semi-perimeter.
which is 30, right?
Yes, miss.
So 30 times
30 times 30 minus a.
30 minus 10 times,
30 minus b.
tell me the figures, what, 26,
24.
and then 30 minus 24. Okay, so let's work those out. So the area would be
The area would be
square
30,
root of, okay, so this
30
30 times
times 20
20 times
4
4 times,
6.
all right, and that gives what?
That would
30
be
times
square
20.
root 30 times 20 is 600.
Mm-hmm.
600 times 4 is 2,400.
Mm-hmm.
And 2,400 times 6 is 14,400.
Mm-hmm. And the square root of that,
And the square root of that is 120
Units.
meters squared.
All right. All right. So let me see, checking my chat. All right. So whose turn now? John?
Okay.
Imani, miss.
Imani's turn. Did John do one of the herons yet?
No, miss.
All right. So Imani's gonna do, and then John. All right. So this one. All right, Imani. So we have 84. Um, no, let me not use those. Let me just use one of the regular triangles, the easier ones. So let's just use the 1086, right?
Okay,
Or no,
miss.
let's use this one. I'll give John the 1086.
What? Miss?
Yeah, it's easier than this one. So we have 50. Why is my mouse doing this? Why is my mouse misbehaving? It's like it wants to do this quickly wiggly. My mouse wants to do this quickly wiggly. All right, so 15, 12, and 9. All right, John, use Heron's form. I mean, Imani, use Heron's formula for this one.
Okay, miss. So the first thing we're going to do is to find the 7 perimeter, and to do that, we're going to find the perimeter and divide it by 2.
All right,
So 12 plus 15 plus 9
so 12 plus 15
plus 9,
plus 9, and
and
that
that would give
gives,
36 meters, miss.
all right, and the
And to
7
find
perimeter,
perimeter, it would you divide 36 by 2,
which is,
miss. That would give you a 18 meters.
all right, so now using Heron's formula for the area,
Yes, miss. So we're going to find the square root of the 7
square
perimeter
root of 18 times,
times 18 minus um, side A, which is 15,
so 18 minus 15,
8, then 18 minus 12, then 18 minus 9.
okay. And what do these give us?
Okay, miss. So 18
Square
minus
root of
miss 18
18
times 3, also 6 and 9.
and those multiply to give what?
Okay, miss. So 3 times 6 times 9. Miss, that would give you 162. So 18 times 162. Miss, and that would give you 2,916. Miss, and we find the square root of that, which is 54 meters squared, miss.
Okay. All right, John, you're up. Thank you, Imani.
Yes, miss.
All right, John. So you get the 6, 8, 10 triangle using Heron's formula.
Okay, miss. So, miss, the first thing we're going to do, we're going to find the perimeter of the triangle, miss.
Mm-hmm.
So it be 10 plus 8 plus 6, miss, which is 24.
Mm-hmm.
And miss, we're then going to find the semi-perimeter, miss. So we would have to divide the 24 by 2.
Mm-hmm.
And that would give us 12 meters.
Okay.
So miss, then we're going to find, then miss, we're going to plug in the 12 meters into the equation.
So square root of
Yes, miss.
12.
Miss, the first number is, miss, the first one would be 12 minus 10,
Mm-hmm.
12 minus 8,
Mm-hmm.
and 12 minus 6.
Okay.
Okay, miss. Now we're going to put it, okay. So miss, it'd be 12 times 2, so 12 bracket 2, and okay, miss, 4 and 6. Okay, miss. So it'd be 12 times 12 times 2 times 4 times 6. I mean 12 times 2. That would be, that is 24 times 4. That is 96 times 6. Miss, that is 550. 576. Miss. 576. And then we're going to find the square root of 576, which is, if the square root is 24. 20, so that's the area of the 24 meters squared.
All right. Okay. So each person got a chance to do the half base times height, and each person got a chance to do the Heron's formula. So the third one would be half AB sine C, right? So that's the one we're going to use. So we use this one. I remember, depending on what you're given, you decide which one to use. So if you know the height, you know the base, or you can easily find the height or the base, most times you're going to be using half base times height, right? Even if it's not a right angle triangle, but you're given the height. So for example, this scalene triangle, you know this length, you know that length. Let's put A, you know, that's X, that's A. So you know the base. Even if you know that, you couldn't use half base times height for that. But if you know, if they give you that, the perpendicular height, if they give you this, you can use half base times height. So it doesn't have to be a right angle triangle. Any other kind of triangle, scalene, isosceles, equilateral, once they give you the perpendicular height and you know the base, you can use it. For Heron's formula, that's if they give you all three sides. If you know all three sides, you don't know any angle, you don't know the height inside, but you know all three sides, you can use Heron's formula. The half base times height, I mean, the half AB sine C is if, for example, it's a triangle, you know the length of A, you know the length of B, you know the angle between them, right? You can find the area of the triangle. So it's half AB times the sine of the angle between them. This would have been side C, so this is angle C. So it's sine of the angle between them. So this is the one we're doing now, half AB sine C. All right, so let's say that's 14 centimeters. That's 21 centimeters. And let's say this angle is 62 degrees. All right, Imani, how would you find the area?
Okay, miss. So it's going to be half AB sine C. Miss, so half of 14 times 21, and you're going to find the sine of 62 degrees.
All right, so we always write the formula that we're using. So it's half of 4 times 21,
Miss, you have 14.
This is 14.
14, sorry, times 21 times the sine of
62 degrees.
62 degrees. All right, so what's half of 14 times 21?
Miss, so 14 times 21 is 294. So half of 294 is 147.
And what's the sine of 62 degrees?
The sine of 62 degrees is 0.8829.
Okay, so just multiply those, no?
Miss, and I got 129.79 degrees. I mean, centimeters squared.
Centimeters squared. All right. And that's it. All right, Asar. Asar, you're up.
Okay, miss.
So let's see now. All right, so let's say we have the triangle looking like that. And this angle is, let me see, 58 degrees. And that's 20 meters and 35 meters. All right, so how would I find the area?
The area would be half AB, half 20 meters.
So half times 20
Times 35.
All right, so half of 20 times 35 times
Sine 30,
58.
times, oh yeah, right. So half of 20 is 10.
Mm-hmm.
And 10 times 335 is 350. Then multiplied by sine of 58.
So you got what, 15?
15 for what?
You're saying what?
I'm
10
saying
times, oh, 350. Okay.
yeah.
So 350. And the sign of 58 is what?
0.85.
Give me 4 digits.
0.8480.
All right. So the area is what?
So the area is 0
0?
no 296.8. How much digits do you want?
Well, for the answer, you can give me one decimal place.
296.8 meters squared.
All right. Okay. And who is next? John?
Miss, I'm next.
All right. So John is next. So that angle there is 40 degrees. And this is 13 millimeters, and that is 18 millimeters. All right, John, what's the area?
Okay. Miss, we first going to find half base times height.
No, John, we're using half AB sine C. We're practicing
Oh
with
yeah.
it.
Half AB times science.
Okay.
So miss, it's half the okay. So miss, half of 18 times 13. So half of 18 is 9.
Times what? Don't work
Oh,
that in. Write out everything first. Times
sine C.
what C?
It's, so miss,
What
I have
what sign of what?
miss, I said sine C.
What is C?
Miss, what do you mean? Oh, miss
The
40.
angle C, the
Miss
sine
40.
of angle C, 40 degrees. All right, so come now.
Okay, miss, so half of 18 is 9. And 9 times 13 is 117.
All right.
Times sine times sine 40. Sine 40.
What is sine 40? Just plug it in now.
Okay. It should be this times 75.206.
Huh?
Miss uh, Miss
What is sine 40? That's what I want to know.
okay. Miss sine 40 is 0.64.
4 decimal places.
Okay, miss 0.6427.
All right, so when you multiply them, what you get?
Okay, it's 117 times 0.6427. Miss that's 75.1959.
All right, so let's round it to 1 decimal place.
Okay, miss meters squared. Millimeters.
All right, so everybody got a chance to do each one, right?
Yes,
So we revised our area of the triangle, the 3 ways that we find the area of the triangle depending on what you are given. So again, if you know the base and you know the height, you don't need to go any further. Half base times height. Whether it's a right angle triangle or not, once you are given the height, you know the base, or you can find a quick and easy way to find either of those, you can work with the half base times height. If you don't know the height, but you're given all three sides of the triangle, you can use Heron's formula. Add the three sides to get the perimeter, divide by 2 to get the semi-perimeter, subtract each side from the semi-perimeter, and multiply those three answers by the semi-perimeter. It sounds confusing, but you just go back up and you'll see that it's not. We just did it, right? Scroll back up and find the square root of that, and that will give you the area. So that's if you know the three sides, none of which is the height. If you know two sides of any triangle and the angle between them, you can use half AB sine C to find the area of the triangle. We also looked at the relationship between how many times greater is the triangle, the bigger triangle than the smaller triangle, if we know the scale factor. And we discovered that if you square the scale factor, and by scale factor we mean how many times the length of the bigger one is more than the smaller one. So if you square the scale factor, you will get how many times the area will be bigger than the. So don't just assume that if the length is 2 times longer than the small one, the area would be 2 times bigger. No, the area would be 2 times 2, 4 times bigger. All right, so that's what we discovered, and we had discovered that for the square and the rectangle as well. Remember that tonight is Thursday night and we'll be having our midnight oil class, our multiple choice CSEC paper 1 class from midnight to 2 a.m. So get your rest and come right back, same place at 12 midnight. And we're going to do, as usual, our 60 multiple choice questions. Until then, scholars, thank you for joining me in studio or out. And I'll see you later.
See you later, Miss.
Bye, Miss.
Bye. Get some rest and come back at midnight.
Yes, Miss.
Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So, stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.